Actually, this is not even going to be your homework. Okay. All right. Right, just as we had postulates and theorems that helped us prove triangles to be congruent, we also have one postulate and two theorems that will help us prove that two triangles are similar. So I think what we'll do is we'll just go through what they are today, and then tomorrow we'll do the application part. Okay? So the first one is called the angle-angle similarity postulate. And basically you'll see it as this A, and then a squiggly line. Angle, angle. And basically what it says is okay, basically, if you have two triangles, and you are either told or you can prove that two of the angles on one triangle are congruent to two of the angles on the second triangle, then you can say that those two triangles are congruent. So if we want to look at it pictorially, it looks like this. If I have triangle RST, triangle MLP, and I can show that angle S is congruent to angle T, and that angle R is congruent to angle L. In other words, it's two. If I just say the two angles on this triangle are congruent to two angles on this triangle, I can then say that triangle SRT is similar to triangle MLP. No, if two angles on one triangle are congruent to two angles on a second triangle, then the triangles are similar. Okay, is there anybody not done copying this? Okay, so just as we had a side angle side theorem of congruency, we also have a side angle side theorem of similarity. Obviously, they're going to be talk about different things because we're not trying to prove that the two triangles are congruent. All right, so here's what you need. One, you need one angle from each triangle to be congruent. So here we have angle Q and angle A. If we're told that they are congruent. Then, if we have the two sides that make up that angle, that's what we mean by the two sides that include the two angles. The two sides that make up each angle. So on the first triangle, we have AB and AC. On the second triangle, we have QR and QS. So these two sides make up angle A, and then QR and QS make up angle Q. If AB is in ratio with the first angle on the triangle on the left, if AB is in ratio with the corresponding side on the second triangle, and on the other side on the first triangle, so here AC is in ratio with QS, then we can say that the two triangles are similar. So what you'll notice is we no longer have to show either that all the angles are congruent, thank you, or that all of the sides are in proportion. Now if we just show that two sides are in proportion and that the angle in between those two sides is congruent, we can say that the triangles are similar. So these theorems, in the theorem and the postulate, is allowing us to shorten the process by which we can show similarity. Okay? Alright, does anybody have any questions on either the angle-angle postulate or the side-angle-side theorem? Pretty confusing. I think when we do a couple of problems, you probably will become legally. I always find it's harder to understand these things in the abstract, and then when you start attaching numbers to them and I show you how it works, it might be easier to pick up. Okay,